Okay, so today we'll take some examples and see where we use and how we use conditions. So we'll start with something simple and see the conditions which are going to do today and loops which we're going to start tomorrow. These are the concepts which are like foundation concept. Okay, uh, no program you can imagine without these two concepts: loops and conditions. Conditions which we have done and loops which we will do next. These are like bricks. Like, when you have to make a wall, you can't make without bricks, right? So these two concepts you have to understand, guys. Okay. If you don't understand, ask me. You have to practice a lot. Okay. Everything else, what we do after that is like learning a new technique. But the core programming ends with loops. The core programming, right, is like whatever we have with loop. After that, what you're going to learn is like new techniques, right? How we can do program better, right? So we will learn new technique. But the foundation, the core of programming is only till loops. So this you have to understand very well. Okay. And if you don't understand, please let me know so that I can, guide you in different way. If you don't ask me questions, if you say yes, we have done it, I'll assume you have done it, right? But if you say no, then I will try to do something different, isn't it? So yeah, just keep that in mind. Okay. So we'll continue with some examples. Now let's say I want to check, okay, if a number is odd or even, right? Check if a now what is the way? How can we check that? How do you know a number is odd? So you take a number, right? And I'll say int of
Divisible by 2. Yeah.
divisible by 2, right? Yes. Enter the number, right? And you divide and take remainder. That's how you know it is divisible by 2 or not. So modulo that we have learned, right? So if I divide number, okay, and take remainder, okay, so if it is perfectly divisible by 2, you don't get remainder. Remainder will be 0. If it is not perfectly divisible, like 5, you get remainder as 1, correct? So if the remainder is 0, then it is which number?
Even.
Even.
Even numbers.
Yes, it's even, right? Else, here there are only two possibilities. Okay, you say print it's odd, right? So let's run it and see. 6, you get even. Now if I enter 5, you get odd. Now what if I enter -9? Now, is it correct? Is it correct?
No,
Why it is not correct?
even a like this is a negative integer.
Negative numbers are not considered as odd or even, correct? Yes. Your number, okay, the even number starts from 0. 0, 2, 4, 6, 8. Odd number starts from 1, 1, 3, 5, 7, 9. Negative numbers are not, they are neither odd or even. They are not considered as odd or even, right? So before I test, okay, 0, I have to check if num is positive or not. If num less than 0, okay, num1, right? If num1 is less than 0, then I will say print it's neither odd or even, right?
Even.
And when it is else, then all these things should be under else. So this becomes your nested condition. So if it is less than 0, not equal to even, because equal to is even. So if it is less than 0, then you say it's neither odd or even, right? So now when you run it, now if I say -9, it goes here, right? If it is 0, this is called checking boundary condition in testing. Okay, boundary condition is if I say less than 0. So did you handle the boundary condition well or not? So check with 0. -5 will be correct, +5 will be correct. The more chances of your condition going wrong is at the boundary condition. So check with 0. It's even. So, okay, that means we have done it well. Right? So if it is 0 or positive, it comes to else. And in else, again, you have set of conditions here to check if it's even or odd. Right? Okay. So this is one example of using conditions. Now let's say, okay, I want to check if, I want you to enter sides of a triangle. Enter 3 sides of a triangle and check if they are, what are the possibilities? Equilateral, then
Acute,
Isolated
acute.
or try right angle.
Acute, obtuse is for angle,
Okay.
right? So even if one angle is greater than 90, then we say obtuse. If all the 3 angles are less than 90, we say acute.
Acute.
Correct? So yeah, so that is based on the angles that you provide. I'm asking only about the sides. So sides you can't check. Can we? I don't think so. So equilateral, isosceles, scalene, okay, and let's say right angled. Now I'm checking right angled. So within the sides, with sides only, I'm checking if it is right angled or not. Okay. How do we check? But before we do this, let's look at another example and then we'll come back here. So I want to check between A and B, which is the larger number. Okay. So check the greater of the given two numbers. So if num1 and num2, you have values like 10, 15, which is greater? So simple, I'll do if num1 greater than num2, then I'll write something like this. Num1 is greater than num2. Correct? So if I run it, nothing will work because obviously in this case num1 is not greater. And I will say else print num2 is greater than num1. Right? 15 is greater than 10. If I make this as 20, then you'll say num1 is greater than 15. Is it correct? Or do we have to do something else to it?
What if we equal?
What if they are equal? Yes. So what if they are equal? We have not handled it, have we? So if we run this, okay, what happens? Is 20 greater than 20?
No.
No. So you have to handle equal to as well in this case. Because it is not, this condition is not true. Okay, since num1 is not greater than num2, what happens? It is coming to else part, because else part means whatever, if the if condition is false, you come to else. That's what it means, isn't it? So in this case, if condition is false, so it goes to else. In else, we are not checking any condition. So if it comes to else, it will be
And is
yes. So what we have to do is, you're right, we have to have elif, and here I have to check num2 greater than num1. So if num1 is greater than num2, it goes here, elif, then I'm checking num2 is greater than num1, right? Now, else is default for equal to, right? I will say print, I don't have to mention the values, I'll say print, they are equal. Right? So in this case, you have to have three conditions. Two conditions are not enough. Right? Okay. Now, what if you have three numbers? Okay. Given three numbers, then how do we handle it? 20, 25, 29. Then how do we handle it?
Using conditional operators.
Of course. But how do we write the condition of what conditions do we write?
One is greater than num2 and num3
Yeah.
or
So
num3.
see, when it becomes little complex, okay, then it's better that you use some pen and paper before you start programming. Okay, you need to use some pen and paper. Now, what we need to do here is called flowchart. Flowchart, okay, will help you to design your concept or your logic. Okay, so this is how I will first use pen and paper till you become comfortable using, directly for programming. So you have three numbers, correct? Now, how does your mind work? If I give you three numbers to check, how do you check that? You compare first two value, right?
Yes.
And whichever is greater, that value you compare with the next one. So first we compare two values, let's say num1, num2. And if num1 is greater than num2, then we compare num1 with num3. Or if num2 is greater, then we compare num2 with num3. Correct? So you will check, is num1 greater than num2? So you get two options, yes and no, right? If, else. So if it is true, okay, and this becomes false. So this will be true when num1 is greater. False means it can be equal to also. Okay, if num1 is greater, then you compare num1 with num3. Is num1 greater than n3? Answer will be again true or false. If it is true, then definitely n1 is greatest of all. And you stop, no further checking. Now, if this is false, okay, then either num1 is equal, num1 is equal, n1 is equal to n3 or n3 is greater. Okay, so in either case, we can say n3 is greater. Even if they're equal, see, we only want to find the highest value, correct? So if it is 50 and 50, both are 50, then you say 50 is greater. You are not wrong. So in this case, n3 is greater. Now in this else, n2 is greater. So I have to check if n2 is greater than n3. Again, true and false here. So if n2 is greater, then obviously n2 is the greatest. Otherwise, n3 is greatest of the three. I just want to find the highest of the three. Correct? So I'm checking N1, N2, and then true and false. Again, in true, I'm checking, so N1 is greater here, so I'm checking N1 and N3, and in false, I'm false in the sense else, right? In false, I'm checking N2 and N3. So let's go back to our program. So I'm checking N1, N3, okay, and else. I just need to know the highest value, right? I don't need to know if they're equal or greater. I just want to print the highest value, greater of the three-way numbers, right? So else. So here that means N1 is greater. N1 is greater than N2. Here else means N2 is greater or equal to, right? That's what it means. Okay. Now I don't have to print here because we still don't know which is greater among N3. So here you will check if N1 is greater than or num1, right? Num1 is greater than num3. Now we have the answer. Okay. Answer is num1 is greater. We don't have to compare to three values. Else, num3 is greater. With me, everyone?
Yes, sir.
Okay, good. Now else. Else N2 is greater. Now I will check. I can copy and paste same thing, right? And instead of checking, because this is else part, so N2 is greater here. So instead of checking N1 and N3, I will check N2. So N2 is greater than N3, right? And I will say N2 is greater, a greatest, whatever, right? And here, obviously, N3 is greater. So now when you run it, so now 29 is greater, correct? If I make this as 29, 29 is greater. If I make this as 29, 29 is greater, right? We don't need to know N1 or num1 or num2. Okay, we just need to know which is greater. So it works if they're all equal also. I make this as 49. Now see, 49 is greater, right? So, okay, so this brings me to a topic of flowchart and algorithm design. Okay, I have a notes. We will not spend much time on it, but I want to show you. I have my own notes which I have made it public, and I want you to go through it, especially those who are new to programming. Please go through this document. Okay, even if you know this is from very basic programming. Okay. Let me see if it's on scribd.com. Okay, so I've got these two books, pseudocode book and flowchart and C program. Now this has programs in C. I want you to see the program, see the C program and convert it to Python. Okay. So if you do it, it will be, I mean, it'll clear all your basic doubt. So I'm going to share this link with you guys. Anyway, you will have these links. Okay. So this is called pseudocode. Pseudocode is writing in a language. It's a programming language, but more like English. It's neither C, nor Python, nor Java. But where I want you to focus is this part, flowchart and C. This talks about, hold on. Yeah. It's so slow. You will not be able to download, okay? Because I have logged in. This is my document, so I get to see download now. You will not be able to see the download option, but you should be able to read it, okay? I'm going to put this. Okay, so this is the document, okay, and you'll be able to scroll down and to each of those 266 pages. Okay, so this is about very basic of programming. Okay, of course, script has its own ads, so you'll have to manage with it. Okay, so this is like how flowchart means, like what is programming. Okay, so programming will have three parts: input, process, output, right? Every program, it doesn't matter how long or how complex or how simple the program is, it'll have three parts, correct? Input, process, output. So input is the data that you need. For example, the last program that we did, greatest among the three numbers. So you need three numbers as input, correct? So input you have is a num1, num2, num3. Process is that steps that we did. And output is, okay, either is it num1 or num2 or num3, which is greatest, right? So you have one output. So input is what you get from the user. Process is your logic, the code that you build, and output is the result of that code that you have built. Okay, conditions. So this is like program structure, logic, okay, inputs at various stages, data inputs, okay, that input that we did, right? Data processing is the calculation that we are doing, plus, minus, into, division, right? Then you have computations and calculations. This also we have done. Okay, logical operations, conditional operators, like, and arithmetic operations, those are really computation. Conditions we are doing. Conditions right now, what we just did, if else is your condition. Branching and looping we'll do tomorrow. Okay, so branching and looping is repeating a thing multiple times. Branching is anyway, what we just did is also branching only. If, so you end up getting two branches or three branches. If you have if and else, you end up creating two branches. If you have if, else, you're getting three branches, right? If you have if, five elifs, and again else, you are creating seven branches. Okay, and looping we'll do tomorrow. Okay, so this 226 is about simple programming, conditions, and looping. Okay, so this is like very basic. So if you are comfortable with basic, you don't have to go through this document. Otherwise, if you're starting from zero, I would recommend that you go through this over the weekend. Okay, it looks 266, but it's not that heavy. Okay, you can easily finish it in 1 or 2 days. Okay, this is how you create flowchart. Okay, what we just did, right? So if you want to do it in a real flowchart technique, these are the symbols that we use. Okay, so this is where you get input. So for example, if I have to convert, let's go to the paint. We'll try to convert the last program that we did in flowchart technique. So always you will have first this thing. This is like your, okay. So here you type start. Okay, after you start, then you need to have input. For input, we use parallelogram. This does not have parallelogram, so we'll have to create our own parallelogram. We'll take this. Yeah, This is our parallelogram. But this is looking more like rhombus, right? We can't, we need to turn it a little bit. This is for asking questions. So this is not the right thing. Okay, so let me try to, I can create it own, but I wanted to use something. Let me, let me do some tilting of this. Okay, so I'm going to, no, not happening. Okay, so let me delete it. Sorry. And I will create our own. So this is parallelogram. Okay, this is what we want. An arrow indicates direction. So you start from start and then you'll say input. Okay, so it is get 3 variables as num1, num2, num3. Okay. Now, now you need to perform check. For check, yes, we use this one. So you'll say n1 or num, let's use text, is num1 greater than num2. Is num1 greater than num2? So this will have yes and no option. So, okay, everything will have only one incoming and one outgoing, except rhombus. This will have one incoming and 2 outgoing, one for yes, one for no. Okay, so let's say this is yes, true, and this is no. So let's first do yes, and then we'll do no. So if it is yes, then again we have to check. Num1 is greater than num2, great. So again you check. This time what we will check? We will check is num1 greater than num3. Okay, if it is no, again we'll have no here. We'll do later. And if it is yes, then the output, right, which is num1 greater than. For output, it is rectangle. So you print here num1 is the highest of all. Is highest of all, right? Okay. Done. Anything else to be done now? No, right? Because this is what we wanted. Okay, one outgoing, we will stop here. Okay, arrow going down. Now, if it is here, no. Okay, then here we know it is rectangle, and you will say num3 is greatest, right? Num3 is greatest. Done. So are we doing anything else? No. This is it, right? So this is incoming, and let's say this is your outgoing. So you will join these two, right? Nothing else. So here we are branching and then we are joining. You'll have only one beginning and only one end. In between, you can have multiple branches, but finally you have to have one end. Now let's come here. This is incomplete. Is num1 greater than num2? No. So now we are checking with num2 with num3, right? So again, you will create this rhombus. So this will have one incoming and 2 outgoing, correct? So now you see, I'll check is num2 greater than num3, right? Is num2 greater than num3? Yes. So yes, we will have separate something here we will do. No means n3 is greater, right? So I don't have to write one more box. I can reuse this same thing here. So now you see here, your This can have multiple incoming, but it has only one outgoing. So if you are here, you will have only one flow going forward. But rhombus can only have multiple outgoing. But everything else will have only one outgoing. So you say you point it. No, you point it here. If it is yes, now you will say here num3 is greatest, right? And you are done. So now you will put it to here. All three branches are getting joined here because your work is done. And then finally you will say, okay, let me, here you create end. Okay, we should create end here only. Okay, the same line, you say end or stop. Okay, and all these will then join here. It's like coming here, everything is coming here, and finally you go to stop. So this is your flow chart for checking, okay, which is the greatest of the given three numbers. Okay, so this is how you use flowchart. So these are the
Third branch that num2 is greatest, no sir?
okay, maybe I got it wrong. Let's go back. Yeah, here num2 is greatest. Yes, you're right. This is num2, not num3. Yes. Okay. Now, if you come back, so these are the signs, right? Start, stop, formula, processing, decision box, question mark, input, output, flow lines, connectors. Let's say you don't have enough space on one page. You want to do something on different page. Then you can put connectors. Okay. So these are the signs. Then you can answer these questions to test. Now you see this. This is a flow chart to add two numbers. Start, read N1, read N2, S equal to N plus N2, print S. Right? So when you see any flow chart, try to write a simple program. Try to convert that into a program. So convert this flow chart into a Python program. That's a task. This is what we just did for checking two numbers between A or B, which is greater. Okay. So now, if you're only printing which is greater, then we don't have to check for equal to, right? If both are 20, you say 20 is greater, doesn't matter. But if you're saying 20 is greater than 20, that's when you have to have three conditions, right? If you're just checking, that doesn't matter, right? So this is one flow chart. Try to convert this into program. Okay, there will be C program here, but try to write your own Python program. Okay, you have more flowchart. This is the this is for converting degrees Celsius to Fahrenheit. Okay, this is one of the assignment which I gave, right? So this converts degrees Celsius. Input is degrees Celsius. Output is Fahrenheit. This is to convert inches to centimeter. So that's why you are multiplying 2.54 into inches. So you get centimeters. This is called, okay, so this is called flow chart, and this is called algorithm or your pseudocode. Okay, this is pseudocode. Pseudocode means it's a code, but it's in English. It's neither for any language. It's for none of the languages, none of the programming language. Okay, so this is like adding three numbers, is it? No. Yeah, checking. So answer is that you have to get 35 in all three subjects. So if you get more than 35 in all three subjects, you pass, otherwise you fail. Okay. So this is how you write the pseudocode, and this is how you write the flowchart. Okay, enough? So I have given this link. Okay, this link will be added. Okay, so please go through this document. Okay, and try to practice. Okay, especially I'm telling you for those who think that programming is difficult, doing programming for the first time, you need some some practice. So please do that. Okay, convert all these flowcharts into programming. Right? Is it okay?
Yes, sir.
It has loops also. Hopefully, tomorrow we'll have some idea about loops, so you can practice even loops. Perfect. Let's go back to our. Okay, so now we'll come back to our program here, which is triangle program, right? Let me comment this part. Triangle, so you'll get sides. Side 1, comma, side 2, comma, side 3. Equal to, let's say I put 30, comma, 30, comma, 30. So here it's like checking multiple values, right? Now you see here, first I'll start with if side 1 is greater than side 2. Now you see, if side 1 is greater than side 2, correct? They are not equal. I'm not talking about equal to, they are greater than. Then what we can do is we can write pass. Now pass is a representation saying that, see, because in Python you do not, you have to have at least one line. Okay, when you have a if block or for block that we'll do tomorrow, you need to have at least something here. So pass is like a placeholder saying that, okay, I will not write something right now. You may not have something to write. Maybe, this will be in the final code, or you come back and you add. Because when you write such programs, there will be multiple conditions, right? Multiple conditions, you'll have 7, 8 conditions to handle. You cannot think 7, 8 conditions at the same time. So you put pass, you create the basic structure, then you go back to each of the passes and replace with the code. So first you create a structure, then you go back and perform one logic at a time, right? You can't have all the 10 logic at the same go, right? So you put pass. Pass means, okay, I'm giving it pass now, but I'll come back later. You may not come back. 1% of cases, pass will be like that only, okay? But 99% time you'll come back and you will change it, okay? So when side 1 is greater than side 2, I'll say pass, okay? Now, why do we need greater than? I can just check equal to or not equal to, correct? Okay. You need greater than because you also need to know right angle triangle. For isosceles, equilateral and scalene, we don't need to know. I just need to know if they're equal or not. If side 1 is equal to side 2, okay, else means they are not equal, correct? So if they are not equal, okay, then I need to check with side 3. If side 1 equal to side 3, pass. If they're equal, I'll be here. Okay, else means side 1 and 2 are not equal. If side 1 and 2 are not equal, then you can have either isosceles or scalene. If side 1 is equal to side 3, that means this is definitely isosceles. Because 1 and 2 are not equal. Right? Else means side 1 and 3 are not equal. So side 1 and side 2 are not equal. Side 1 and 3 are not equal. But 2 and 3 can be equal. So I have to check one more condition here. If side 2 equal to side 3, then they are isosceles. And else they are scalene. Correct? Now same logic goes here. Now we'll replace past with the value here. Side 1 and side 2 are equal, great. Now I need to check if side 1 and side 3 are equal or not. So if side 1 and side 3 are equal, then they are equilateral. Right? Now, what condition should I check here? If side 1 and side 3 are not equal, then it comes to else. Correct? But if they are not equal, 1 and 2 are equal. So if 1 is not equal to 3, of course 2 is also not equal to 3. Then here you have isosceles. Right? And your assignment for today is modify this program to handle equilateral triangle. Right angled triangle logic. Any question here? Make it 60. Isosceles. Make it 90. They are scaling. Right? Any doubt? Any question? Try this and we will discuss it tomorrow. All right? Okay? Take care, guys.
Okay, sir.
Yeah, I'll share this. Take care and we'll see
Okay,
you
sir.
tomorrow. Bye.
Bye, sir. Thank you.
Thanks.
Thank you. Bye.
Bye.